Hello students, welcome to lecture of Kinematics and Theory of Machine. Myself Professor Patel, and we are going to continue gear train, and in this lecture we are complete the examples of epicyclic gear train, which is most important because in all example we will follow same rule and we will repeat the steps. So let's start. So first of all we have to study the tabular method, which we already completed in last lecture, but I want to revise that very quickly. So first of all, some student may have some queries, so I will solve that in this revision. So first of all, why we use this tabular method, and how we can find these other speeds of different gears. So first of all, check this. So whenever you know the relation between two gear when they are simple gear train, okay, like two gears are there and you know the RPM of one, you can find the RPM of this gear 2, okay. But when we are talking about the epicyclic, gear is rotating as well moving forward, so RPM, output RPM will be minor difference. So that's why we assume this first thing is the arm is fixed, so arm is not rotating, and when you assume the arm is fixed, these two gears became the simple gear train because one is rotating and with respect to second is rotating, there is a no moment is here. So as you know, first thing we assume the arm is fixed, so arm RPM will be 0, and after that any one gear we take and give the one revolution, we give the only one revolution, plus one revolution, and because of that plus one revolution we get the RPM of gear B, which is minus TA by TV. And always remember that driver upon driven, always this will be same. If you consider one another column and I am saying that there is a C, what will happen? T above TA upon TC, so it will be same. Always driver is on top and bottom, in bottom what will whose this column will be at bottom because it is the driven, okay. And sign plus or minus depend upon the orientation. So check this. So first of all, whatever the configuration or the assembly, always arm will be fixed. You can see here the arm, you can see here. So arm will be always name the arm of here and give the 0 RPM, and after that most important point is choose any one gear, and it can be assumed this A or B, anything you want in system. Any gear you choose as a first driver, maybe A, B, C. You can see here there are lots of gears, and among them any gear you can choose here and give plus one revolution. And if you give the plus one revolution to one gear, what will happen? All other gear will rotate. So, and the relation we will find by this ratio. So all other gears C, D, all will be next columns. So choose any one gear and give plus one revolution, and according to that all gear will move some, and this relation we will find. So for easy calculation, always we choose the outmost gear like this O, A, or smallest gear which is as a center, okay. We avoid to choose these central gears because otherwise we have to go to both side, outside and inside. So always we choose any center gear like C, and we check this, C is rotating, D is rotating, E rotating, G, means inside to outside or outside to inside, okay, for easy method. Okay, and after that what we are doing? So after that we are doing same, but X revolution, means arm is 0, always arm is 0 and plus X revolution, and you get this relation. So remember that always when figure is given, start with table, and if you find this data perfectly, then your answer will be correct. because if you make any mistake in this table, your answer will be absolutely wrong. And table is the first step. If you make any mistake in this first step, your answer will be wrong. Okay, so remember that we need this perfectly, so always make table. But this table is assumption. I am repeating this. This table is assumption, means I am taking this system and fixing this arm and giving 1+1 revolution to this center gear. This is my assumption, and on this assumption I make this table. But as in given data, maybe arm has some revolution, gear has some other revolution, so don't read the given data first. Always make this table first, and after that we will start the reading the given data. Always as per this configuration we make this table first, and after that we start for the reading for the given data. Okay, so I will revise the procedure for any gear train example. Okay, so first of all, there is a two category, means diagram is given, means figure, this assembly, C is connecting to B is connected to what, so whatever the configuration is given in a drawing. Okay, so for that what will you do? First of all, make table. If figure is given, don't read the data, we don't need during that making the table. So first read the make the table, and for table you know that all we need is a direction of motion, means C is rotating. If we are going to give the motion in anti-clockwise direction, so revolution of this C is plus, and if C is connected to B, the direction will be negative, so minus, and B and A are internally connected, then it is also this minus, means clockwise, so anti-clockwise, clockwise, clockwise. So this type of relation we need to check first, and we make the table. Okay, and after that when this table is ready, okay, so you know that how to make this table already. First, arm is 0, put all gears C, D, A, B, C all, and give any one revolution for a first gear, and due to that all motion will be we find by this method. And after that multiply X plus Y and summation of these two row number 2 and 3. Okay, X plus Y, and always there is a Y plus Y will be there, and in second column X plus Y will be there. Okay, so after that what we will do, when table is ready, then we read the given data and all the numericals from the gear train. Okay, I can say that there is always some teeths are missing. They give the teeth of C and B, and always there will be unknown teeth. Any one gear we will find the teeth. Okay, so how we can find this teeth? Okay, we will check this in an example, but I will give you quick how can we find the teeth. So first of all, check this. If I cut this diagram in half, what you can see here, the radius of this C plus diameter, this diameter of B total, okay, is equal to radius of A. And this relation of radius and diameter, as you seen in a compound gear train, converted into the relation of teeth, and you will find the teeth. Okay, and in given data always 2 RPM is given, always, and among them one is always 0. They will say this gear is fixed. Okay, in easy example they say this directly, gear A is fixed, so you can write this. But as you go for harder example, they will confuse you by giving lots of elements are there, and some elements are fixed, some these elements are rotating, confusing for make the example hard. Okay, so always remember that there will be 2 RPM will be given, and among them one is a 0 and other is some data, means some value, numerical value. So we have to find what is which gear is fixed and give the RPM 0. Okay, and after that when you find the 2 RPM from the given data, what you will do, you will do this equation. You will find, means if the gear, means this from comparing these two RPM to any two, and you will find X and Y. So most important point, when you find X and Y, your example is almost complete. Means after you find the X and Y, you can find the any RPM from these columns. There are maybe lots of gear are there, and you can find any RPM from any gear, okay, by comparing, means putting all value in this bottom of the column, okay. So after that you will find the RPM, but there are some level up, means second means harder examples are there. In that there is a without diagram, okay, and you can't start with this table, because when diagram is given you start with the table. But when you when the example without diagram, first of all you have to make the diagram, which is very complex. I am repeating, which is very complex, because when this assembly is given, C is connected to B, B and E on the same shaft, and this type of, you have to read very carefully and make the diagram, because any mistake in diagram, your table will be wrong and all other steps will be wrong. If you can't make the proper diagram from given data, your example will be wrong, okay. If I put this C gear outside and A gear inside, and find the RPM of C at the end, but it will be wrong, completely wrong, okay. And other thing, in without data, when the data you read the data, there will be some RPM is given and all data is given, and this makes this example more confusing, okay, because our assumption is arm is 0 and A is +1 revolution. What will happen when in given data there is a RPM of A is 0 is given, okay, so what you will put here 0, which is very wrong, okay. Our assumption is giving +1 revolution, but as per actual in a machine there will be some revolution to A, okay. So that's it. Let's start our first example in epicyclic. So first of all, this figure is given, so we don't need to read this given data. Let's start with a table, because if you read this data, this will make you more confused for the table. So let's start with the table. So you can see here how many gears are there. So first of all, there is a outer annular wheel, which is known as a annular, which is larger wheel, and B, A is connected to B, okay. B is connected to C gear by this arm EF, okay. This is the construction already given. So let's start with the table. What you will do, there will be first this column, in that arm, okay, arm EF is given. After that, in this I am considering the C gear C as a main driver. I am putting C here. You can put A here also, okay. So I am assuming C is a main driver, C is connected to B, B is connected to A, okay. And after that, what you will do, you will do EF as a 0, C as a +1 revolution, and if C as a +1 revolution, C rotating B, so for B, driver is a C and driven is a B. Always this type of relation will be there. And A is also driver, which is driven by the C, okay. You can put directly here C is driver and driven is a A, okay. But how that is here, check this. So check here what will happen. You will give the +1 revolution +1, and B is rotating in a clockwise direction, because we have given the anti-clockwise in for C. So check this, this will rotate in a clockwise direction, and due to B, A is also rotating in clockwise direction, so both will be minus. You can say both will be negative. Clear that? Because internal gear, this gear is internally connected. Okay, but after that, what is here? Check this. This gear A is rotated by gear B because A and B connected, and you can write this B by A, but B is RPM of B is a minus TC by TA. So okay, so final our formula will become this minus TC by TA. Okay, and you can simply write this by putting main driver upon whose column is this A, so A will be there, so B is a driven will be there. Okay, so that's it. Let's, and after that we are multiplying this by X. Okay, or in second language we are putting plus X revolution to C, so 0 plus X minus TC by X minus. Okay, so after that plus Y revolution to all, and after that plus Y, X plus Y minus X. So okay, now we have figured, and now we are going to read this given data. Epicyclic gear train consists of 3 gear A, B and C as shown in figure. Gear A has a 72 teeth. Internal teeth means there will be inside teeth will be there, internal teeth. Gear C 32 means 32 here, and gear B mesh with A and C. Okay, so this figure is given and carried by the arm EF, which rotate about the center A at 18 RPM. So whose RPM is given? Arm EF. RPM of this arm is given 18. And after that, if the gear A is fixed, so 2 RPM is given, A is fixed means NA is equal to 0. Okay, NA is equal to 0 and NEF is given. Okay, let's check this. So this data is given, teeth of 2 gear A and C. Teeth of B is not given, and RPM of EF and A is given. Okay, one more thing, the 18 RPM, but I have taken this plus because in example when there is a no description is given anti-clockwise or clockwise, we can take assumption it is a anti-clockwise and take at this as plus. Okay, so whenever the direction is not given, we consider will be positive, means anti-clockwise. So teeth is not given, so first of all we are going to start find the teeth. And how can we find the teeth? So let's start. We divide this in a half. Okay, and radius of this gear A, larger gear, is equal to, you can write the radius of C plus diameter of B. Okay, radius of C plus diameter of B is equal to radius of A. Okay, and you simplify this by 2, and when we have to make this equation in form of diameter always, because we can write in a radius, because there will be all radius or all should be in diameter. This formula, when we replace it by the teeth, this total formula should be in a form of all radius or in form of all diameter. Okay, remember that. So we can put all the teeth, we already we know that, and we find the TB is equal to 20. We find the teeth of B is 20. Now we know all the teeth. So let's start. TA, TB, TC, this B. Now we have know the teeth of B. This 2 RPM is not. What we have to do? We have to check our table, and in our table there will be our last row is very important. Last row is very important, and we are going to use this last row of our table. So which data we have, and we are going to use these 2 data, RPM of EF and RPM of A. How we can use that? We will compare this with our data. RPM of EF is equal to this column. So we can write this Y is equal to 18, because this simple I have already told in lecture. This is the RPM of EF as per our table. This is RPM of C this is RPM of B, and this is the RPM of A. So we have to compare this data with this given data. Okay, so let's start this. So RPM of A is given is equal to 0, and in our table RPM of A is this. So we will compare that and find the X and Y. Y already known, so we can find the X here, and value of X and Y. When value of X and Y is known, you can find any RPM from our table. Okay, so let's start. We are going to find the RPM of which is value is X plus Y. Okay, so RPM of C is X plus Y, and RPM B is Y minus X. So we have to put this value of X and Y and all teeth, which is already known. So we put this value. Okay, so this is the RPM of C, and you can find the RPM of B also, X and Y and all teeth. So these three value we have to find before finding this, otherwise you can't use this table. Okay, thank you. So that's it. This is the first example. Always remember that we have to find X and Y properly, otherwise your answer will be wrong. And we have to write this here, means plus sign is there, so we have to write here this is the anti-clockwise. Okay, and same we have to write here, this is also positive, so we will write here plus anti-clockwise, which is means same opposite to